Hi, I'm Paul. We're doing Leetcode must-know interview questions, and today's challenge is kth smallest element in a BST, binary search tree. So we're given the root of a binary search tree and an integer k. That's the input to the method. Pointer to the root of a binary search tree and an integer, k. Return the kth smallest value, 1 indexed. So there's not a 0th smallest value. The smallest value is 1. Not explaining that very well, but there is no 0th smallest value. Let's say that. There's a first smallest value of all the values of the nodes in the tree. And this is rated medium, even though it doesn't seem that hard. Let's look at an example here. Both of these examples are actually a little bit too simple, but we are going to do a depth first search. We're going to do an in-order traversal. You can think of it that way, but we're going to do a depth first search. To do a depth first search, we use a stack, and let me not set up right here. Okay, let me get oh, there we go. Come on. Let me get a pen. I need white. I need a white pen. All right. So in this example, this is the tree, and k equals 3. All right. So we're going to use a stack. I'm going to simplify this a little bit. We're not going to check for no nodes and stack being empty and so on, because that's actually not going to happen. But to get this thing started, we push the root node on a stack. And the root node is 5. All right. Now, in-order traversal is left node right. So we are going to look for nodes on the left. And there is a node to the left of 5, so we'll push that to 3. Now we'll look for a node to the left of 3. And there is one. That's 2. And we'll look for a node on the left of 2, and there is one, and it is 1. Okay. Now we pop the stack. If we pop the stack, we get 1, and that the 1 is no longer on the stack. We subtract 1 from k, and we ask ourselves, is it 0? And it isn't. So, because an in-order traversal, or because an in-order traversal is left node right, we're going to look at this node 1. The reason that we stopped at 1 is because it doesn't have a left subtree. So we process the node, and then we look and see, does it have a right subtree? And it doesn't. So, all right, so we'll start the loop again and pop the stack. All right, so we pop the stack this time. We're going to get 2. Okay, 2 comes off the stack. And we decrement k. Okay, decrement k. We ask ourselves, is this 0? And it isn't. Now we look for the right subtree of 2, and there isn't anything. All right, so we go back up to the top of the loop again and pop the next element. Okay, so it's not going to be 2 anymore. And the 3 is what we're going to pop. Okay, so we pop 3, decrement k. We say is k equals 0, and it is. So the answer is 3. Once k hits 0, then the answer is whatever node we just popped, 3. I apologize for that example being so simple, but I mean that's what we got. And it really is not a hard problem anyway. But let's go ahead and do the implementation. All right, so we need a stack. There is a stack class in Java. It's sort of considered a legacy class. And so if you don't want to use it, it's okay. We can use a double-ended queue, a deck, which can work as either a queue or a stack. We'll call this one stack and say that it equals, good God, equals a new, and we need some kind of implementation. Deck is an interface. Deck, new array deck. Okay. We get this thing started. Well, let's see. Okay, so we have the pointer, and we are going to loop through. Hold on a second. What happens if there's nothing found? Is it guaranteed that something will be found? It doesn't say what to do if nothing is found. Well, let's just proceed like this. If we want to do an in-order traversal of the whole tree, we are going to loop so long as the root passed in is not null, or the stack is not empty. If both of those are false, then we don't have any more nodes to process. I don't really know what to return in that case, but let's just go ahead with this. All right. So as we're going to push as many left child nodes as we can. So while root is not equal to null, I don't even like calling this root because it sort of suggests you know, that we're always talking about the root node of the tree. Let's just call it node. While the node is not equal to null, we are going to push it on the stack. And we are going to move to the left-hand node. All right. Once we've gone as far as we can go with that, and in this example, we can push 5, we can push 3, we can push 2, we can push 1. Once we try to access the left child of 1, it is null. So, while node not equal null, we're going to drop out of that while loop and start processing the stack. And we're going to say node equals stack dot pop. If, and let's do the subtraction before we do the 0 check. If subtracting 1 from k gives us 0, then we found the kth smallest number and we'll return node.val. All right. So we processed the left node. We processed the node. Now we need to process the right node. Okay? 1 doesn't have a right node. So we do nothing. We just move back up to 2. And actually, because we have already, for 2, we're already right here. We are after line 24, where we pushed the left node. So the next thing is to pop the stack. We'll get a 2. Decrement k is equal to 0? No, it isn't. And then we will process the right-hand node, right-hand child of 2. There isn't one. Okay? So we'll go back up to 3. For 3, we're already here. We've already pushed, we've already processed the left child. So we pop the stack, we get a 3. Subtract 1 from k, is it equal to 0? It is. Return the node value, it's 3. Node equals node.right. I honestly don't know what to return if the, well, wait a minute. If there's not a k at the smallest node. Well, wait a minute now. What are the constraints here? So k, I guess there has to be a k at smallest node. If there has to be at least one node and k is greater than or equal to 1, it's also less than or equal to n. So it's between, so k represents a number between 1 and n. So k would be in the tree somewhere. But Java is going to complain that this method returns an int, and we're going to get down here and we're going to drop out of, well, you know what though? We're not going to drop out of the while loop, but it's still going to be a compile error because as far as Java is concerned, it doesn't know that we're always going to execute this statement. It's just going to see this and say, you are not returning an integer on every possible path. So let's just return 0. Okay. And then run. All right, accepted. Good. Submit. No. Wow, most people did better than that. 33.65. They got something that rounded to 0. Let me run it one more time. Ah, that's better. These run times and memory usage are just, they're not like super consistent. But I guess if you're just talking about numbers that are so small, like the program is running somewhere on the order of like 0 to 1 milliseconds. It might be that yeah, it might be just a rounding thing, or I don't know how many other submissions are running at the same time. But anyway, so this is a binary search tree. We're going to do an in-order traversal and just count the numbers. The kth smallest number is just the kth smallest number. You do an in-order traversal, you're going to get the smallest number, and then the next smallest number, and then the next smallest number. And so you just count them till you get the kth smallest number. And that's it. Hope you enjoyed it. Please feel free to like, comment, subscribe, and see you next time.